Good afternoon, everyone. We'll give a few minutes to let people get here into the presentation, and then we'll get started. Okay, thanks everyone for joining today. Welcome to What You Need to Know, Safety and Handling of Permanganate webinar. So let's just go over a few housekeeping items before we get started. We are recording this meeting and everyone is kept in listen-only mode. If you have any questions during the presentation, we encourage you to submit those throughout the presentation using the question pane in the GoToWebinar panel, or you can email us directly. If you submit questions through GoToWebinar, we do receive a report at the end of the webinar with the question and your contact information so we can follow up directly. And we will at the end of the presentation answer a few questions if we have time. If you're interested in receiving a PDF or a recording of the presentation, please contact us. We encourage you to share the recording within your network. There's my email address and it'll also be up at the end of the presentation so that you can grab it so you can email us directly. Let me introduce myself. My name is Darin Skutt. I'm a Senior Technical Service Specialist with Carus. I've worked at Carus for 25 years, with the last 22 years in the Technical Solutions Group. I conduct laboratory testing, product demonstrations for our customers in the municipal, drinking water, wastewater, industrial and remediation, and also for new customers. We also do technical training, safety presentations, installation of safe chemical handling and dosing systems as well out in the field. I am a graduate from Illinois Wesleyan University, Bloomington, Illinois, and my bachelor's degree is in chemistry with ACS certification. I am a member of AWWA, the Water Environment Federation, and the American Chemical Society. Thank you for joining us today. So what I want to begin with, since we're talking about safety training, is I want to begin let you know that Carus is a member of the American Chemistry Council, ACC, and as a member, we participate in the ACC's Responsible Care Initiative. The ACC provides broad guidance aiming toward no accidents, no injuries, and no harm to the environment. There are several important principles that form our program, but none more important than to protect the safety of our workplace staff and of our customers. Today's program is one part of our ongoing safety communication efforts. As you can see there under responsible care, we want to make sure that we meet and have a secure facility, we reduce our emissions to the environment, we use our energy efficiently at our plant, and then like we're going to talk about here for the rest of the presentation, employee, transportation, and process safety at our plant, getting product to you, and then product safety and communication when you're using our product at your site, and then all of that ties into accountability. Carus is RCMS certified as well. One thing to let you know, we do have safety goals at our plant. Because we want every employee to arrive safely at work each morning and return home safely each evening, we emphasize understanding and practicing chemical safety at our plant, just like you should at your facility. Our annual company safety goal is 0 recordable incidents, and we want the same for you using our chemicals at your workplace. Training webinars such as this are one of our product safety communication program, and our goal is to continually upgrade and improve the information and the way that we communicate with you. Now, we have a wide range of customers on this call today, and they use a wide range of different Carus permanganate products. This presentation is going to cover all of the following products. So our potassium permanganate products, which would include Carus potassium permanganate in the US, Aquox potassium permanganate in the EU, and then Remox S-ISCO reagent used for remediation products both here in the US and overseas. On our sodium permanganate line, it would be the Carusol and Carusol C, sodium permanganates used in the drinking water municipal applications, Liquox liquid permanganate used in pharmaceutical synthesis and industrial applications, and then the Remox L-ISCO reagent used in remediation projects worldwide. Each of these products that you see listed there has a specific data sheet, an SDS, and there are a variety of case studies for different applications for these products if you want it. If you would like additional information on one of these products or a case study about a specific action, please reach out to us and we can provide that information to you. So let's start by reviewing some chemistry here at the beginning of safety and handling. First, a reminder, we're focusing just on our permanganate products. Permanganate products are a chemical category that is identified as an oxidizing agent. Oxidizing agents are a form of energized oxygen, and they're useful in synthesis and purification chemistries. Permanganates are also a manganese chemical. The element manganese is found in the periodic table next to iron on the first row of transition metals, and it's an important part of the formula, as you can see here above, KMnO4 and NaMnO4 for both potassium and sodium permanganate. The properties of these oxidizing agents and of manganese compounds are what drive the regulations as far as safety and handling of these products and how you're going to have safe storage, transport, handling, and disposal of our products. Now, permanganate products are manufactured, packaged, and delivered in one of two types. The crystalline solid that you'll buy is going to be potassium permanganate, and there's multiple grades, but in general, it's going to be over 97% active, and it's going to look like the purple to grayish sand picture that you see there on the right-hand side of your screen. The reason for kind of the grayish color is there is a free flow additive that can be added to permanganate to help prevent lumping and clumping, and so that adds kind of a grayish color to the crystal itself, whereas if the free flow is not additive, it looks more like the dark purple that you see below. Then there are concentrated liquids, both 20 and 40% active ingredient, and that's going to be sodium permanganate. It's going to look, to the picture to the left, almost pitch black, right, in that picture, but it is a purple liquid, and as you dilute it down, it's going to look more and more purple versus the distinct dark blackish color that you see there with the white cap. Potassium permanganate, when you put into solution, is going to generate the same purple color as well. So that picture that you see there in the middle of the page will be what permanganate solutions look like when you dilute them down. Now, one of the things to talk about is the hazard potential of the chemistry. The hazard potential of permanganates is sometimes a little difficult to understand, and it's really based on the concentration of the product. So here's a visual to help kind of explain this idea. The graph is divided into three zones. Green is low risk, yellow is moderate risk, and salmon red is high risk. And here's what the diagram illustrates. The hazard potential for permanganate product increases with increasing concentration. When permanganate is dissolved in water, as potassium permanganate is, it's going to be less than 6% by weight. The risk of that weak solution at 6% is going to be there in the green range, and typically most customers are making somewhere between a 1 and a 3% solution, so they're not even trying to get max solubility of 6%. You'll be in the green zone. It's not quite as reactive because of that much lower concentration. Now, liquid permanganates fall into the yellow zone. They are going to be packaged at 20 and 40%, where you see the red triangle. So you're in that caution zone. They are more reactive because of the higher concentration with other materials like cotton and paper towels, and we'll talk about that throughout the safety presentation. If you do take 20 and 40% sodium permanganate in, and you dilute it down before you're doing your application, and you get it down into that 5–6% range, you're going to fall back down into where the potassium permanganate solutions are in the green zone. Now, the highest risk is going to be dry potassium crystals. Dry potassium permanganate, greater than 97% purity, so it's got all that oxidation potential in there. In this form, if it's involved in a fire, it's going to provide a ton of oxygen and help feed that fire if permanganate's involved in that. Now, specifically, the first step in worker safety is knowing the risks. What can hurt you and how can that happen? There are three situations that really define the potential hazards of permanganate use. There is the oxidizer hazard. That's going to be unanticipated reactions with incompatible materials. This situation is potentially hazardous when concentrated permanganate products are mixed together with substances that they can chemically react with. Because the permanganate is concentrated, a mixture such as this will generate and release heat. Note, permanganate does not react with all substances, only a select group of reactive materials, and we'll talk about that throughout the presentation. But one of the easy ones is you can dilute permanganate down, it does not react, and it's just a dilution reaction, and it doesn't generate any heat. So you can take dry permanganate, or 20 and 40%, add water to it to dilute it down to a solution of, say, 5 or 10%, depending on the product you're using, and it does not generate any heat. There is no reaction that goes on there. Now, if you then take permanganate, say 20, 40%, or the dry permanganate and mix it with something like ethylene glycol antifreeze, that is a potential reaction. Immediately, it's going to generate heat and catch fire. So there are things you're going to want to avoid, and we'll talk about that in the safety and handling and storage. One of the additional hazards is aquatic hazard. Environmental hazards may occur because of a large release of permanganate into the environment in a body of water. It may adversely affect aquatic life. Or if it's improperly disposed of, that can result in situation one. So you have a release and it comes into contact with something that reacts, and so then you cause a fire. Or you have a release and it gets to a river or stream downstream and it's at a high enough concentration that it can affect plant life and animal life in that situation. And then finally, there's the health hazard. Regarding human safety, exposure to permanganate by ingesting or breathing in permanganate, or externals such as splashing on skin, eye, clothing when handling it or doing spills or cleaning up a spill. Most of the health effect hazards are associated with exposure to manganese dust from the dry permanganate and breathing it on a regular basis, and are chronic long-term exposures, such as someone handling it in our plant, or if a water operator was using it on a continuous basis without any PPE, which would not be recommended at their site every day, and were exposed to the dust. For most users, short-term exposures are more important, where sensitive tissues such as the eyes may be exposed and can result in immediate injury. So worker personal protection equipment is always required, and we'll cover that. You get kind of two things with permanganate. It's a corrosive, slightly, and if you're using the dry permanganate, because it's crystalline in nature, it's abrasive. So if you were to get that in your eye, it's like rubbing sand in your eye in addition to the corrosive. So that's why you want to have a concern when you're handling it. And we'll talk about proper PPE for your eyes. Now, how do we get the word out to you as our customers? Communicating the potential hazards, the precautionary actions, the specific worker protections, the remediation options is all accomplished through a variety of methods. In addition to the webinars such as this one, the common routes are shown above. So obviously you have the safety data sheet here in the US and in Europe. There's also a chemical safety report that's available in Europe, which is tied into REACH. You'll see it on our package labels. You'll see it on the pictograms, both on the SDS and on a product label. And you'll see it on warning placards when the product is being transported on a truck. As our understanding of product applications and as government regulations change, these communication routes may also be reformatted or revised over time. So you'll see changes over the years. This brings us to the biggest change that's happened in the last 10 years. It's the Global Harmonized System, GHS, for hazard communication. There was a drive for consistency or harmonization in the way the information is delivered worldwide to all customers. Our presentation is in part designed to inform you of the changes that have impacted permanganate product safety communication, and you'll see that throughout the presentation. So, like every safety training, the most important piece of safety literature is the SDS, the safety data sheet. When did this change? So it's almost been 10 years. In June of 2015, the GHS compliant safety data sheet replaced the previous material safety data sheet at that time, the MSDS. This switch to the new name of an SDS signified a lot of changes. One of them was every SDS is now a standard 16-section format. Also, globally standardized red, black, and white pictograms are part of the format as well. You can see there on the front page of our safety data sheet for Carus potassium permanganate, the very distinct red pictograms below. And we'll cover those in the next couple slides. The safety data sheet is available for crystalline permanganate or the specific product you buy. So if you're buying Carus or Remox or Aquox, request the specific MSDS. All the cautionary information is related to the dry material, which is greater than 97% active. When it is stored and handled properly, permanganate is stable and easy to use. But it is an oxidizer, and if the dry powder is mixed with incompatible materials, it can generate heat. However, like I mentioned earlier, when it's dissolved in water as a dilute solution, most of the acute hazards are eliminated. As I mentioned earlier, potassium permanganate hazards are self-limiting because at room temperature, the strongest water solution that you can make by weight is 6%. Water is your friend when working with permanganate. The SDS for Carus potassium permanganate was updated in July of 2023. You can see the current version there to the side, and if you'd like that, you can request it from us directly. So on the SDS, specifically those pictograms. So for the health hazard pictograms that are required for crystalline potassium permanganate, these pictograms apply to all package sizes. So whether you're buying it in a 5-gallon pail, a 55-gallon drum, a cycle bin, or bulk product, or super sack product, all those pictograms are going to apply. The health and safety categories here that you see are new and based on the latest research data when the GHS update was. And there are 4 categories in the toxicity rating system. Now, in this case, it's the reverse of the NFPA diamond. So it's always one I like to point out. With the new GHS standards, the greatest hazard would be category 1, and the lowest hazard would be category 4 for these hazards. That's the reverse with NFPA diamonds. In NFPA diamonds, 0 and 1 are the lowest categories. 2, 3, and 4 are higher categories, and it's the reverse for the pictograms. There is a separate rating system for corrosivity and irritation potential, so you'll notice that there's a number and a letter. So specifically for permanganate, you have acute toxicity oral, category 4. So you would have to ingest the permanganate, so it's the lowest hazard because you're ingesting it. For skin corrosion irritation, that's category 1C. For serious eye damage irritation, that's category 1, so that's the highest hazard. Reproductive toxicity, unborn child, would be category 2. Specific target organ toxicity, repeated exposure, this is going to target the brain, would be category 2. If you'd like additional information about how those categories specifically are called out, you can go to OSHA.gov site, look at the HAZCOM standards, and they'll give you what each of those different categories specifically mean, but the number is telling you 1's the highest hazard, 4 is the lowest hazard. Now, permanganate also has the physical hazard. So permanganate is an oxidizing solid. It falls under category 2 for crystalline permanganate, and that pictogram you see is always the flaming circle for oxidizers. There's also an environmental hazard for potassium permanganate. It's hazardous to the aquatic environment, acute hazard, category 1, and it's hazardous to the aquatic environment, long-term hazard, category 1. And this is when you have active permanganate. That pictogram is the dead tree and the dead fish. Obviously, we don't want to release a permanganate out to the environment at large dosages because it is an oxidizer, so it can react with stuff like plant life, fish, water fleas out there in the environment. We'll talk about that more at the end of the presentation when we talk about transportation and reportable quantities. In addition to the new pictograms, You'll now see signal words, hazard statements, precautionary statements, and they're all new to permanganate labels. They're better designed to define the health and safety impacts of the product being used. They're not a replacement for the SDS, but they contain a lot of the exact same information directly from the SDS right on the product label, so that if you're looking at the product and you don't have the SDS handy, you can read the product label to get some of the general information, and then you can follow up to get the full SDS and read it. So on that product label, there'll be a name, address, and telephone number from the company that you bought the product from. There'll be a specific product identifier. So in this case, Carus potassium permanganate technical grade. There'll be a signal word in red. In this case, there are two signal words you can choose from. There'll be no signal word, there can be warning, and then the highest one will be danger. Potassium permanganate has danger on the label. Also on the SDS. There'll then specifically be hazard statements that you can see below. So a hazard statement, a precautionary statement, and then there'll be supplementary information like maximum use level. A lot of our products go into drinking water, so there's an NSF certification and a maximum use level for using that product in drinking water as well. So specifically on the label for potassium permanganate, you'll see those pictograms, and then you'll have the precautionary statement, which has three categories. It'll have prevention, so obtain special instructions before use, meaning you should know what permanganate is with the data sheet and the SDS. Do not handle until all safety precautions have been read and understood. Permanganate's an oxidizer, so you want to keep it away from heat. Take any precaution to avoid mixing the dry permanganate with combustibles. Keep store away from clothing or other combustible materials. Do not breathe dust, fumes, gas, mist, vapor, or spray. In the case of dry permanganate, it would be dust. So when you're handling permanganate and moving it around, you can generate dust from pouring the permanganate. There are no fumes that come from permanganate. In the case of Mr. Vapor, if you were making a solution of permanganate and then say you were spraying it onto an area, you would be seeing the permanganate droplets in the air. It'll be a purple mist. You don't want to walk into that without breathing protection. You'd want them to fall to the ground, but they're going to fall rapidly because it's a liquid mixture, so it's going to go. You want to make sure you wear protective gloves, protective clothing, eye protection, face protection. We'll go into each of those individually in the next several slides. Do not eat, drink, or smoke when using this product. Wash thoroughly after handling the product and avoid release to the environment. The response category under precautionary statement, in case of a fire, use appropriate media for extinction. So we'll talk about that later in the presentation. If you do swallow permanganate, rinse mouth. Do not induce vomiting. Immediately call a poison center doctor. If you were to get some exposure, take immediately off all contaminated clothing. Rinse skin with water, shower, and wash the contaminated clothing before use. If you do get it in your eyes, rinse cautiously with water for several minutes. Remove your contact lenses if present and easy to do so. Continue rinsing and then consult a physician. If you're to breathe in a large amount of dust or mist, remove the person to fresh air and keep comfortable for breathing. As far as storage, recommended to store the product locked up. It is an oxidizer. And dispose of contents containers in accordance with local, regional, national, and international regulations. The specific hazard statement for potassium permanganate is going to be may intensify fire. It is an oxidizer. Harmful if swallowed, can cause severe skin burns, eye damage, depending on the quantity and what else is on your skin. Suspected of damaging the unborn child, can cause damage to organs, brain through prolonged use or repeat exposure. This would be internalizing the permanganate. So in a lot of these cases, it's either going to be breathing the dust over a long term or ingesting dry actual permanganate. Specifically for liquid sodium permanganate, a safety data sheet is also available for this product. And it's available for the specific concentration that you're getting it. So there'll be one for Carusol C, which is 40%, and Carusol, which is 20%, or the Remox product or the Liquox product. As with dry permanganate, when concentrated liquids are stored and handled properly, they are stable and easy to use. Liquid permanganate, just like dry permanganate, is going to be a stable product. So today, 6 months from today, a year from today, 2 years from today, both liquid permanganate and potassium permanganate will stay at the same concentration. They will not lose strength. So if you bring permanganate onto your site and it's 20% active, it'll be 20% today, a year from now, 2 years from now. It's not going to lose strength over time. Other things like peroxide and hypochlorite do lose strength over time. So just to give you a comparison there. In the case of liquid products, we often get a lot of questions about the potential for releasing gases or mist or vapors because it's referenced on the SDS. There are no vapors other than water vapor that releases from permanganate solutions because they're a salt solution. Our packages are shipped completely sealed. They do not require venting. So when you get a tote of sodium hypochlorite or hydrogen peroxide, that requires a vented tote because there'll be released gases and build up, and the tote could, or the drum could balloon. In the case of permanganate, we're fully sealed. There is no off-gassing, so we don't need to have that vented cap. Concentrated liquid permanganate is an oxidizer though as well. So mixing it with incompatible materials will generate heat. When you dissolve it in solution or dilute it down further, the hazard goes away. One thing we want to keep in mind though is if you're working with the concentrated 20 or 40% directly, it can react with cotton, rags, paper toweling, and it will react at a higher rate because of the higher concentration or 20 or 40%, and it could possibly start to smoke and smolder and catch fire. So we have a lot of times where we've heard customers over the year, they've wiped up a spill of 20 and 40% on a cotton rag or a piece of paper toweling. They threw it into the dumpster or the trash can, and 10, 15 minutes later, they saw smoke coming out of the trash can, and that's from the permanganate at the high concentration or 20 or 40% reacting with the paper toweling rag, and then starting to react with stuff in the garbage can as well that's oxidizable. So you want to keep in mind. In that case, water is your friend. Dilute it down, put the fire out. So one of the things that's going to change during this presentation is there is a new SDS coming out for our liquid permanganate products. This updated SDS and labeling will be coming out throughout 2025 for customers using our sodium permanganate. Liquid permanganate has new health hazard pictograms. These pictograms apply to all package sizes. The SDS was updated late in 2024. And it was for the first product was Carus C, but it'll be rolling out to all the other products here at the beginning of 2025. One of the things you'll see is you will see the old product label until we deplete inventory. And then once we change inventory, the new label will come out as well. It continues to be an oxidizer, so you still see the burning circle, but the health hazards have changed slightly. So what you see here in this case for sodium permanganate is the specific target organ toxicity, single exposure, has changed. And now rather than central nervous system, it targets brain, but it still stays at category 2. So that is the big change besides the NFPA diamond that we'll talk about here at the end. As far as physical hazards, sodium permanganate is still an oxidizing liquid, specifically listed as sodium permanganate. It is category 2. Workplace eye safety. So why take a chance? Protect your eyes. So there's two concerns when handling both dry potassium permanganate and liquid sodium permanganate. Dust from dry potassium permanganate can get anywhere. So in that case, we recommend that people wear goggles if they're going to be handling a lot of dry permanganate. Primarily, they protect the eye from a variety of airborne particles, specifically the dust, which can be pretty fine when you're handling dry permanganate. In the case of chemical liquids like liquid sodium permanganate, or if you've taken potassium permanganate and made a liquid version of it, it really depends on how much handling you're doing of the product. You can use safety glasses if it's minimal handling. We would recommend upgrading to goggles if it's going to be a lot of handling or it's a higher concentration liquid permanganate solution. And you could put a face shield over the goggles to give you a secondary protection besides your eye, also protect from getting it on your face skin as well from chemical splashes when you're transferring the product as well. So specifically for both dry and liquid permanganate, eye protection must be worn when handling the product. Permanganate decomposition products are slightly alkaline and may cause burns that result in eye damage. The eyes are very sensitive tissue and must be protected. Like I mentioned earlier, there's an abrasion concern with dry potassium permanganate because dry permanganate crystals are sharp and abrasive. So if you were to get them in the eye, they can also cause an abrasion issues. Eye protection, like I said, is very important. Typically what we recommend and what we use in our facility and what you'll want to do at your facility is use goggles when handling concentrated liquid products or when your exposure to dust would be high. So say you're dumping a pail into a dry feeder, so you're moving 55 pounds and you're not doing it by hand by scooping it, you're pouring it. There's a lot of exposure for dust. We would level up from safety glasses to goggles. If you're transporting liquid permanganate and you're transferring from a drum to a tank or from a tote to a tank and you're transferring 20 or 40%, there's a chance for a large amount of splashing there if your pump's not hooked up correctly or if a line breaks during transfer. So we would say not safety glasses, we would go up to goggles, and you could also add a face shield. When our drivers make bulk deliveries of liquid sodium permanganate, they will have safety glasses or goggles underneath a face shield while they're making the delivery. The other important thing for eye protection is you're going to want an eye wash fountain nearby or the little eye wash bottles so that you can flush your eye out if you were to get permanganate in your eye, if it somehow got around your protective equipment. Now we do have an additional safety recommendation. So at our manufacturing facility, eye protection is our #1 priority. We changed our eye protection requirement at our plant. We use fully sealed safety glasses that have a gasket material that you see there in the picture around the outside that fits tightly to your face. We also have many different styles of these glasses on site because people have different sizes and shapes of faces. So you want to make sure that you have the best one for proper fit to your face. These glasses also have anti-fogging or prescription lenses available that you can purchase. They're not a replacement for goggles, but because of that gasket, they provide a better seal for general use. So it's much harder for stuff to get around that seal and get in your eye at that point. What you should do specifically at your site is review your handling procedures and how much exposure you'll have. And then you can determine, are you going to level up from safety glasses to goggles or to a face shield before you're handling the product at your site. The next part of safety is going to be inhalation. You do want to provide adequate ventilation when handling dry permanganate. Handling dry permanganate does involve some dust when you're moving it around. Airborne concentrations of permanganate in the form of a dust can be irritating to the respiratory tract. Pretty much all this applies to the dry permanganate. When you're transferring the material from its package into a storage hopper, a fine dust can be released. If you're dumping a large amount of product into something to mix it in, that's also an exposure. Or if you're air conveying product into a hopper or to a storage silo, obviously there's a pace with air conveying. You put air behind it to transport it. If there's a crack or break in the line, it'll spray dust or powder out into the air. Permanganate dust is a distinct irritant because it's an oxidizer, and breathing it should be avoided. Permanganate specifically, besides being an oxidizer, is a manganese compound, and inhalation exposure is based on a manganese ceiling value of 5 milligrams per liter of manganese per cubic meter of air. And also on the SDS, there's a time-weighted average of 0.1 milligram of manganese per cubic meter of air. You will see the dust in the air at those levels. What we recommend that you wear is a NIOSH MSHS approved dust or mist respirators are recommended. We at our facility use Carus N95 masks, but you could also use dust masks that you can find out there that have the N95 or K95 rating. We level up at our facility because we're handling the product on a more regular basis, and so it's just an extra precaution, and everybody these days is now familiar with the N95 mask. You also, if you're going to have to wear them long term, other than say you're wearing it for 10-15 minutes while you're handling the product, which would be normal for our customers, you have to have a respiratory program to comply with OSHA standards if you're going to be handling the product on a routine basis throughout the day. So like at our manufacturing facility, they're exposed to permanganate all day long in pack out. So we have an OSHA regulation around that. It's you as the customer to determine the risk of dust or mist in your application to protect against the risk. So there can be some engineering controls like ventilation, but there also can be the level of dust or respirator that you use. One thing I like to point out, because it does get asked once again, is solutions of potassium permanganate or sodium permanganate do not give off any vapors. They do not give any gases off. The only thing that would come off a liquid solution would be water vapor. The permanganate will stay in solution and will get more concentrated as water vapor comes off. Where you would be exposed to a mist would be if you were pumping the permanganate and there was a break in the line or a pinhole leak in the line, and under pressure that sprays the permanganate out into the air, you would see a purple mist or a purple cloud in the air that's going to drop rapidly to the ground once the pump is stopped. But physically, you would see that with a liquid permanganate coming out of a pump. If there was a break in the line, you would see that mist of purple in the air. You'd physically feel it like raindrops walking through it. So you would know not to go into that area, do something to turn the pump off, or wear proper PPE before you'd even go into that area to handle it. Final piece of worker safety PPE, skin contact. Permanganates will react with skin oils, and they will leave a brown to black stain depending on the amount of concentration that you have on it. Highly concentrated liquid permanganate can attack the skin along with those oils or contaminate the skin. A lot of times it's a reaction between something on your hands besides the oil and greases that are natural. So say you're working with a piece of equipment, it has an oil or a grease that you're working with, you have oil and grease on your hands, you then work with permanganate, the reaction between the two generates heat, and so that you have the reaction where you have more of a concern. Gloves should be worn when handling permanganate. We use chemical resistant PVC or Teflon coated gloves in our plant. Cotton gloves should not be worn. Cotton reacts with permanganate. We also commonly use nitrile lab gloves because that gives you all the finger dexterity. So if you're working in a thing where you need all your finger control, you can use the smaller nitrile lab gloves. If the level of exposure for you would be significant, like the delivery of a bulk liquid permanganate, then you would wear an apron. So that would limit exposure. So the apron that you see there in the picture, obviously from a leak. If you were to get permanganate on you or on your clothing, remove it immediately as the products could be corrosive, and then go to a safety shower and wash off. If at our facility, and the same thing at your facility, if you're going to do non-routine work with permanganate and you don't know what your exposure would be, it'd be great for you to do a specific job safety analysis to assist you in establishing risk mitigation plans to reduce exposure, such as leveling up your PPE or trying a different way to complete the task at hand. So all this PPE that we've talked about is really site specific to what you're doing and handling it. So if it's something that you've never done with permanganate before at your site, you're trying something new or trying a new application, then you'd want to do a review before that. Finally, permanganate is an oxidizer. So do not eat or drink permanganate. And this is true of pretty much every chemical at your plant site. You always want to wash your hands before eating, drinking, or smoking. If permanganate were swallowed, it can cause severe burns to the mouth, throat, esophagus, and stomach. If you were to ingest permanganate, immediately rinse your mouth out and drink plenty of water. You do not want to give anything to the victim who is unconscious or having convulsions. Do not induce vomiting. If vomiting occurs, keep head low so the stomach content doesn't get into the lungs. You'd want to get immediate medical attention. This is all covered in Section 4 of the SDS. This would be if you were exposed to a large amount and you're eating a large amount of it or drinking a large amount of permanganate. You can imagine we've had people where a pump is broke and it sprayed a little permanganate in someone and it's a few droplets. There'd be a case where you'd rinse your mouth with water, drink plenty of water, and there's not much exposure. This would be drinking or being exposed to a large amount. As far as storage requirements, concentrated permanganate products and the potential hazardous conditions that you should be aware of. Permanganate products are manufactured and packaged in containers made of compatible materials, typically high-density polyethylene or metal containers for our products. When permanganate is repackaged into smaller container sizes, you want to make sure that you use the proper container materials as well. So transferring from a metal drum, to a pail that's also high-density polyethylene, or transferring from high-density polyethylene drums to high-density polyethylene pails, just keep in mind that you've got the right material compatibility. Like I mentioned earlier, under normal conditions, permanganate is very stable and has a shelf life of many years. So it's not going to break down over time. It's not going to lose strength over time. Now, there are a lot of things that permanganate can react to. Permanganate can react with compounds like hydrochloric acid, which would result in the release of chlorine gas as a byproduct. So you would not want to have a mixture of those two things at concentrated forms. Permanganate could react with sulfuric acid, forming manganese heptoxide, which could be explosive. So you would not want to have those things. Kind of the more common ones would be oils and greases. We have a list of compatible oils and greases that you can use with permanganate where they're not reactive. And there are oils and greases that are reactive where it would start to generate heat, could start to smoke and smolder, and then possibly catch fire. And then obviously I talked about the big one, which is antifreeze, ethylene glycol. Ethylene glycol and permanganate is very reactive. It's going to generate immediate heat. It's going to generate immediate smoke and fire when those things react. So you want to keep in mind to store it away from those things. As normal, you also want to protect the containers from physical damage so that you don't have a leak or a spill that you have to clean up for. One of the things that I've seen many times in my 25 years in the industry is people are moving stuff by forklifts. And especially with liquid products, it's very easy when you're moving something by forklift and the forklift tines are too far through the pallet, you can hit the product behind it. And we have had customers before when they're moving liquid permanganate in totes or in drums, they have forked the pallet or the tote behind it with the forks. And then when they pull back out, you now have a leak in the container and you're leaking liquid permanganate on the ground that you need to burn or contain. There is more information on the storage requirements under Section 7 of the SDS. Material compatibility, like I said, if you're transferring it from container to container, that's important, but also your application is going to be important. We receive many questions about equipment, pipe, gaskets, tank materials when you're going to be storing or handling or feeding permanganate products. We have prepared guidelines and suggestions for compatible materials for each of our specific permanganate products. These guidelines are based on lab testing and on our experiences in our manufacturing plant, from published reference materials, from equipment suppliers, and from customer experience out there in the field. New material are always being developed, and if we are not familiar with them, we can run simple tests to determine short-term acceptability for those materials. One word of caution for you: common materials can be sourced from many different manufacturers, and they can be produced in many different grades. A particular product and manufacturer may work well in one case, but a different manufacturer of the same material may work poorly in another case. We have piping standards, material standards that have been established, and we also have that list, like I said. You can see here for potassium permanganate, materials that you can use for storage and handling and transport. We also have this for liquid permanganate, which also will call out manufacturers that we commonly use. You don't specifically have to use those manufacturers. It's just ones that we and our customers have had a ton of experience using out there in the field. So we have a history and know that those materials are compatible. Thermal stability of permanganate. Permanganates are normally very stable. Oxidizers are not considered in this case for permanganate flammable, but they will support combustion by giving off oxygen. So when permanganate's involved in a fire and they are exposed to a heat source, they will decompose through the reaction that you see above. So permanganate is the MnO4- ion, and then as it gets exposed to heat, it'll go all the way to giving off O2 that you see there at the end of the reaction. In the case of crystalline permanganate, decomposition starts at 302 degrees Fahrenheit. So if you have a fire, you're going to reach that temperature. Liquid permanganate decomposition starts a little bit lower, but same thing. If the building's on fire and permanganate's in it, permanganate's going to provide oxygen to that fire as a source. So fighting fires involving permanganate, you're not going to extinguish it by smothering it with foam. With an oxidizer, it's going to be water to put the fire out effectively. The NFP hazard code specifically is another way to communicate the hazard to first responders regarding the health hazard, the fire hazard, the reactivity hazard, and the special hazards or identifiers for that product. The numbers would be low, little hazard 0 to the highest hazard of 4. Specifically, for potassium permanganate, the NFPA hazard code is 3. Under fire conditions, it will give off irritating combustion products. Flammability hazard is 0. It's non-flammable. It does not burn. It supports combustion by providing oxygen. The reactivity hazard is a 1. It's normally stable. It's not reactive with water, so we can blend it with water and there's no reaction. And then always with permanganate, you're going to see the special hazard OX for oxidizer. So this is the thing you'll have on your tank or the outside of your building, so first responders can look at that to give them an idea of what the hazard is before they deal with it. For sodium permanganate, since the SDS was recently updated here at the end of 2024 going into 2025, the NFPA diamond has changed. It is still a 3 health hazard. It is still a 0 flammability hazard, but the reactivity hazard has changed from a 1 to a 2. So it's still normally stable, not reactive with water, but the change from 1 to 2 is because of changing standards. But because of the higher concentration, 20 and 40%, it can be more reactive with other materials. And you still see the same special hazard OX for this product. So what's the best bet for fighting a fire? Use large quantities of water to fight a fire. Berm to contain the water. What you do not want to use is dry chemical extinguishers such as CO2, halon, or foams. Those work by smothering the fire, preventing oxygen. If permanganate's on fire as part of that building, it's going to be providing its own oxygen. Now, that question comes up a lot of times. Well, if I have a trash can fire or I have a dumpster on fire, what chemicals can I use? Easiest would be water. Water's going to put the fire out immediately. But if it is a small trash can fire, there's not a lot of material that's going to be there. Then you could use a dry chemical extinguisher. So what usually happens with a trash can fire or a dumpster fire is it's a rag or a small spill, and that's been wiped up on a rag, and then you throw that into the trash, and then it's all the other combustible materials that end up catching fire and reacting, and then CO2 or a foam would put that out. So if it is just a small trash can fire and it's not a lot of permanganate, you could use a CO2 extinguisher, but water is always your safest bet. This is all covered in section 5 of the SDS. As far as spills, product spills can and do occur. Like I said, you can be transporting the product, moving it, and you fork it, or you drop a container and it breaks open if it's a plastic pail. What you want to do, you don't want to move or transport the leaking permanganate because now you're going to spread permanganate all over the place. You want to basically contain the leak to where it's at. Containment may include patching the container for a temporary move, picking the product up and putting it in a plastic containment pallet or an overpack container. Don't use cardboard, chipboard, or some other combustible material to collect the permanganate up. It's a combustible material. It now is in contact with permanganate. If you were to clean it up for dry product that's spilled out of the container, you want to sweep it up, shovel it, and then transfer it to a clean metal drum and dispose of according to approved local regulations. The reason we would say don't return it to the original drum, you don't know what was on the floor before, so you spill permanganate on the floor, it's going to pick up that contamination, and if you were then to pick up that contamination and put it back in the drum, if it's something that turns out to be reactive, but it takes a little longer time, you're now exposing it to more permanganate. What you really want to do is take that permanganate and, because you don't know what else it's been exposed to, put it in a clean metal drum and then dispose of it according to local regulations that way. The other thing is a lot of our customers are drinking water. you're going to take it off the floor. You don't want to put it back into the container that you would put it back going into the drinking water that goes to the customer, because once again, you don't know what was on the floor. Dilute permanganate solution spill cleanup. So what you're going to want to do is contain or isolate the liquid, so either in a pit or a holding area, or make a temporary berm with a pig hazmat sock. If you're using the concentrated 20 or 40% solution, you're going to want to dilute it down to less than 6% before you neutralize it. There's a lot of ways you can neutralize permanganate using a solution of sodium thiosulfite, sodium bisulfite, or a ferrous salt. We'll talk about another cleaning solution as well. This is covered on section 13 of the SDS. And you can specifically ask us for materials that have been tested and found to be compatible with 40% liquid permanganate. We use specific pig hazmat absorbent socks, Spill-Tech absorbent pads, and United Absorbent polypropylene absorbent pads. A lot of those will be different colors. So we have gray and yellow and orange ones that we've used both in our plant and out in the field. They're non-reactive with permanganate, so they can pick up or soak up a spill of 20 or 40. And then once they've picked up that spill, you can then go rinse it out in a sink to lower the concentration and then neutralize it at that point. Water is always your best friend when working with permanganate. If there's a concentrated liquid or dry permanganate is spilled and you've gotten the majority of the dry permanganate, but there's still some dust left behind, you're going to want to dilute that with water to less than 6% prior to neutralizing it. Do not wipe up spills, clean up drips or leaks, or wipe down equipment with a dry rag. What we recommend is have a bucket of water available, wet the rag with water, wipe up the spill with the wet rag, and then rinse the water in the bucket continually to lower the concentration. And then you can dispose of or neutralize the water that's in the bucket at that point. If your clothing becomes contaminated with permanganate, get that clothing off, especially if it's cotton, and then rinse yourself off in a safety shower. Permanganate should be stored on a concrete floor in normal handling. Just want to bring this up. It's a concern. Never place garbage in a container with permanganate. So if you're at a site and you're wiping up a spill, you want to make sure that there's no permanganate left in that rag or piece of paper toweling before you throw it in a garbage container. Because what happens is in that garbage container, you'll have all sorts of other reactive materials. You could also have other liquids. And then what's going to happen is those are combustible materials. They start to react with the permanganate to generate heat. And then you can have a small trash can fire. So always something to keep in mind. As far as permanganate neutralization, like I said, neutralize it down to less than 6%. And then you can completely neutralize it with different solutions. In this case, sodium thiosulfate or sodium bisulfate solution. Permanganate is going to give you a visual indication. Permanganate is a purple solution. As it reacts, as you can see there in the picture, it's going to go from purple to brown, which is manganese dioxide. And then as you apply more of the cleaning solution, the brown will go to soluble manganese and it'll look clear. It'll completely remove the stain. So typically what we use, that is a typical plastic weed sprayer with all plastic parts. And you could put a sodium thiosulfate or a sodium bisulfate solution in it, or you can make our vinegar and peroxide solution that I'll talk about in the next slide and use that for cleaning up a small spill. So say you've gotten some permanganate on yourself. It got around your glove, it got through your glove because of a nick or a cut or scrape in the glove. What we would suggest for cleaning up yourself would be a cleaning solution that's 1/3 water, 1/3 part white household vinegar, and 1/3 part 3% hydrogen peroxide. So all stuff that you can buy at your local grocery store or your local pharmacy. Never use this cleaning solution on sensitive tissues like eyes, mucous membranes, open wounds, or burns. If you have a nick or a cut or a scrape on your hand and you use the vinegar peroxide solution, it's going to burn. It's going to clean it, but it's going to burn. You don't want to add this to concentrated permanganate solution. So like I said earlier, you want to dilute down to less than 6%, and then you can use this cleaning solution. We have customers that exclusively use this to clean up all the spills they have, because generally it's just a few leaks or drips or a small spill, or they've gotten some permanganate on their hands or clothing. And this is a way to completely neutralize the permanganate from purple to brown and then all the way to clear. But you can use, if it's a larger spill, the more concentrated products. Finish up here with hazardous materials regulation. In the United States, domestic shipments of hazardous commodities over the highway is governed by Title 49 of the Code of Federal Regulations. What it does is it identifies and classifies hazardous materials. It establishes quantity limitations, so how much the truck can carry. What is the proper packaging for that product? How do we need to specifically mark and label the package? What shipping certificates and what regulations do the driver need to qualify? And then it details how we need to placard the vehicle during transporting the shipment to your site. Specifically for permanganate, there are 2 ID numbers. So crystalline potassium permanganate falls on under number 1490, and its hazard class is an oxidizer 5.1 in packing group 2. So that tells us how we have to package it to ship it to you. Liquid permanganates, inorganic, aqueous solutions, will cover sodium permanganates, and it's UN 3214. It's still oxidizer, it's still division 5.1, it's still packaging group 2. The truck, when the product is being transported to you, should have the oxidizer 5.1 symbol on it. Whenever we ship permanganate out of our facility on a truck, it will have the oxidizer 5.1 placards flipped for transporting permanganate to your site. Now, in addition, there are 2 acts that cover permanganate and chemistries and disposal or release of permanganate into the environment. The Resource Conservation Recovery Act, RCRA, establishes 4 characteristics of hazardous waste: ignitability, corrosivity, reactivity, and toxicity. Permanganate itself specifically identifies as an oxidizer under the ignitable waste characteristic and specifically lists potassium permanganate under the Resource Conservation Act by name. Permanganate also falls under the Comprehensive Environmental Response, Compensation, and Liability Act, or the Superfund Act. A crystalline or liquid permanganate released to the environment must be reported if it exceeds the reportable quantity. What are those? Specifically at this time, dry crystalline potassium permanganate has a reportable quantity of 100 pounds for a release to the environment. Liquid sodium permanganate, while it is still an oxidizer, still does not have an established reportable quantity. What does a reportable quantity mean? What that means is this is a release outside your fence line into the environment. So if you're handling permanganate at your site and say you dump some product on the ground next to your feeder at your facility, that's not a release to the environment. That's a release within your facility. It's contained. You can sweep or clean it up, transfer it to another container, and then dispose of it properly. Say you have a leak of liquid product. So a drum starts leaking on your site. As long as that product is contained on the floor or a pit or a holding area and does not go outside the fence line of your building, then it's not a reportable quantity as well. So just keep that in mind. You want to call the National Response Center when you have a release to the environment. Where that typically happens is we've had cases in the past where there was a truck accident and it's on the side of the road and containers were broke open. So then that's a release to the environment during transportation because it's outside someone's fence line. Or we've had customers in the past where they have both sewer drains and drains that go to the storm sewer, which would be a release to the environment, and they've had a spill that's gotten into the storm sewer, which means then it's going to be released to a river or stream, and so then that would be a reportable quantity that you would have to release. As far as disposal of your containers, permanganate is considered ignitable waste, so it should be through a licensed disposal company. Or you can find alternative uses. Sometimes we have customers that use permanganate in drinking water. They stop using it for one reason, or they switch products and they want to dispose of some. Wastewater applications for odor control are used a lot. So you could find an alternative use within your own community where someone's using permanganate on the drinking water side and they want to dispose of it on the wastewater side for odor control. So removing hydrogen sulfide from sludge or from wastewater. For the packaging must be triple rinsed to an absence of pink color, and the label needs to be removed prior to proper recycling or disposal. So that container needs to be rinsed so there's no permanganate left. Permanganate gives you that distinct color, so if there's no pink color left, it's clear water. that container is clean, and then remove the label or mark the label out completely before disposing of it. As far as larger containers, permanganate containers are designed for single use, so they're not returned or refilled or recyclable to us. When the container is emptied, there are companies that we work with that will collect them, and what they do is they recycle the plastic generally, and depending on the shape of the cage, they'll recycle the metal of the cage as well, or they'll put a new liner in it. We get this question all the time. In the case of permanganate, empty really does mean empty. No permanganate. Triple rinse with water, no residue. The recycling disposal company will not take residual permanganate in any concentration. So we have customers that use totes or drums, and they'll say they have a small heel with, say, an inch of product in the bottom. That is active permanganate. That's an oxidizer. You need to completely empty the drum and dispose of it. So there should be no pink visible in the rinse water of the container. And in the case of a tote, it's easy. You can rinse the tote and open the bottom valve to drain that to your facility. Typically what we would say is move the containers to a place where you can easily clean them with water and dispose of that water at that point in time. If you would like information on companies that pick up the drums and the totes, reach out to us. We work with Mauser and other companies, and we can get you that information directly. One thing I just want to bring up. Customers should always audit their safety and handling procedures for permanganate at their facility to ensure they are up to date. You're using the product properly, you have the proper PPE, and you're not doing something differently where there's an exposure that you could eliminate by looking at that. For SDS, other technical information, please contact your regional account manager or myself in the technical solutions team or our EHS&S department. You will find that information at our website. Contact us, our team, and you can reach out to each of those individually. Specifically, my contact information is there. There's my office number, my email. You can also get a hold of me by my cell phone. Our EHSS group, Shelley Corbin, is Corporate Product Stewardship. There is her phone number, her email address. You could also call the 800 number or the 815 direct number, or reach out to us on our website or on our sales and marketing at Carus email as well. At this time, look to see what questions we have. So the question we have says, say you have a potential leak from injected potassium permanganate to treat groundwater coming to the surface via nearby spring. Best way to handle neutralize it of surface water. So if you're dosing it into water, you can buy sodium bisulfite solutions. So those are dechlorination agents. So Univar, Brentag, a lot of distributors will have liquid sodium bisulfite. That's available, and that can do the neutralization for you. So you can buy it in a liquid or a dry form. In the dry form, you'd make it in the liquid, and then you can meter that in directly to neutralize the permanganate. So the purple will go to brown to eliminate the active potassium permanganate. Another question, if you're injecting potassium permanganate, what's the maximum solubility? So at room temperature with a lot of mixing, you can get up to 6%. Typically what we recommend that customers do for solutions with potassium permanganate is going to be around a 3% solution is probably the easiest to make. Math-wise, that's a 1/4 pound of dry potassium permanganate per gallon of water. And generally you need about 15 minutes of mixing and you'll get a 3% solution to go into solution with mixing. When you start to go to 4 or 5 or 6, you're starting to stretch that where you'll need 30 minutes, an hour, or several hours of mixing. And the risk is when you start to get to 5 to 6, if you don't get good mixing, you'll end up with crystalline dry permanganate in the bottom of your container. And dry crystalline permanganate, if it goes through a pump, it's abrasive, so it can damage the pump or it can plug feed lines. So that's why we typically say the easiest thing is a 3% solution, a 1/4 pound per gallon. That's once you've got 15 minutes of mixing, you've got it in the solution. It'll be very easy to feed or meter out to your application point. finish up here, we're just a little bit past. Will we be sending out a copy of the slides? Specifically request that. You can either do that in the question pane, or you can send me an email at the email address or the sales and marketing email address, and we will get you a copy of the presentation. And then we also can send you out a link to the recorded webinar if you want to share it to other colleagues that you work with as well. And with that, thank you for your time today. If you have any additional questions or didn't want to send them here or want to talk about a larger application that you have, please feel free to reach out to us at Carus. We're always available to answer your questions as well. Thanks for your time.